Cool. Thank you, everyone. You're good to go.
Thanks. There we go. Okay. Okay, I'm doing this all from slides, and I'll incorporate this into the book properly afterwards. But I thought, so basically I had some previous material on this, and I thought it'd be useful to kind of step out a little bit from some of the biology examples as well. So this is using this wine ontology that we've been using for training within our group. So disjointness, what is it? Well, I think maybe the best way to think of it is it's our main means of building in some error checking into the ontologies that we build. If you use more fully expressive OWL, then there are other ways to do that. You can say things like not, but because we build everything in OWL-EL so that we can use the ELK reasoner, we're a bit limited in the error checking that we can add, but we can actually do, we could probably do a lot more than we currently do right now with more use of disjointness. So very quick dumb recap. So actually that should not be overlapping there. You can see, so on top, the way that I'm going to present this is using these kind of Venn diagrams. This thing just here should not overlap at all. This should be entirely enclosed. So the idea here is to represent classes as circles, and those circles might intersect each other or not. So in this case, here's the class of all wine, and you can say that white wine is a subclass of wine. That means the class of all white wines is entirely inside this class of wines. And here's another class, colors, and white and red are entirely within those. Some classes, when we build ontologies, don't intersect, so they have no subclasses or no instances in common. It's not possible for them to have subclasses or instances in common. And it can be useful to record that, so in case you make a really silly error, like putting a wine under a color or a color under a wine, you can say that that's not allowed. Nothing is both a wine and a color. So we do that with this disjoint with, which you can add just like you would add any other axiom in the description tab on a class in OWL. So like you would have a subclass of axiom, etc. You can add disjoint with. Actually, if I just switch to this one. So actually, I already added it there, so I can just simply say, okay. Can you see that okay? Is that a bit small? Maybe
no, we can see. I can see it.
Okay. Okay. So I can click disjoint with, and I could add specifically that nothing is both a wine and a color. There's also quite a nice option which you could use if you right click. Maybe that's not working. There's this weird thing called make primitive siblings disjoint. If I click this, then now color, wine, so all the siblings basically become disjoint. So now I can say nothing is a color, nothing is a region, nothing's a varietal. I think probably in most of what we're building, that's a bit too dangerous thing to do. It's probably best just to add them individually as you think of them being useful. But okay, so back to the talk. So you might not always think of it this way, but relationships are classifications too, really. So what we tend to call a relationship, I guess partly coming from the obo world, we write as a subclass of a relationship in OWL. So we could say red wine subclass of has color some red. So what we're saying there is, here's the class of all the things that are red. So I've got red wine and red currants, maybe strawberries, and I don't know, other red things here. So this is an anonymous class. I could make a class called red things using this, but in this case, I haven't made a class called red things. I've just made, I'm just referring to this anonymous class has color, all the things that have color red, and red wine is a subclass of all the things that have color red. So if you look in, maybe if we choose wine, you can see. So here, Barolo is a subclass of has color some red. It's a subclass of has made from some Nebbiolo. So it's a really, this is just a way of diagramming this. So given that, we can also make we can also say that some anonymous classes don't intersect, they're disjoint. So we could say nothing is at the same time both red and white. So nothing has color white and has color red. And we do this with this general class axiom. Again, you can just add this. So if we go here, let's say, actually, I think I already added one earlier. I'll show you again. So I can say, just like you would normally do for adding subclass over equivalent to, I can say, has color some red, disjoint with has color some white. Okay. Now, okay, so I could now say, let's say I invented a wine here. Let's add a wine. And now if I say it's a subclass of that has color some white, it's a subclass of has color some red. And now if I run the reasoner, there we go. It's now gone red. It's a subclass of al nothing. If I click on the explanations, there we go. So a made up color has color red, has color white, and then this says nothing can have color red and have color white. There's my error checking. And that would fail in most of the pipelines that we run on, using ODK. Your pull request would fail if assuming that the ontology is not too huge and we're able to run this whole thing as a test and a pull request. And it certainly wouldn't make the release. There's some argument maybe that this is kind of a sledgehammer to crack a nut and that we shouldn't be causing these massive inconsistencies and trying to debug them, but that's the way we work for now. And you can see it shows up in red here. And any class actually that directly references this class would show up in red as well. Okay, so yeah, this is just another quick example from another version of this tutorial. So this is probably a case which maybe is more defensible and you're more likely to come across. So if you're building an anatomy ontology, you might want to say, nothing is part of the head and part of the tail, or in this case, nothing is part of a leg and part of a wing. They don't spatially overlap at all. So I can make this disjointness here, and then if you accidentally add some entity that's part of a leg and part of a head, you'll trigger the error. Any questions so far? Too fast? Do you want to go back over anything? Or, got some exercises we can to play with as well. So.
I think it's great so far. Thanks.
Okay. Okay, I did that one. Right. So one thing, so you might have come across domain and range, and I think that's something that maybe gets misunderstood quite a lot. Domain and range are actually positive things, and they really become powerful when they're combined with disjoints. Powerful is a way of error checking when they're combined with disjoints. So if I say that the relationship, the object property has color, has the range color, then if X has color, some Y, or it could be individuals, if X has color Y, then Y is a subclass of color. If X has color some reddish green, then reddish green is a subclass of color. Okay, so I'm saying a positive thing here. How was I going to go and show addition? Okay, so I can. So let's get rid of this made up line. Right, so I can go to object properties, and there we go. I already added it there actually, but it has color, and I can just simply type color. I could do an expression here as well if that made some sense. So you could have a range which was, I'm not part of the head. It's a bizarre thing to do, but it's the expressiveness is there to be able to do it. And domain is just the other way around. So if X, let's say we had a relation color of, then okay, so region of maybe might be a nice one. Region of I'm using to relate one geographical area to another, so I could make these both geographical areas, domain and range. So if let's say New York State is a region of the United States, and the domain of region of is geographical area and the range is geographical area, then you would infer that both New York State and the United States are geographical areas. Okay, so easy enough to add. Now, so let's look at some examples that we might work from with the with this wine ontology. Here's kind of a simple one, not very useful. So we've said has color, has the range color. So then if we say red wine has color some red, then the reasoner infers that red is a subclass of color. Now we already classified probably red as a color, so that's not that interesting or useful. But what if I accidentally, when building this, said instead of Barolo has color red, I said Barolo has color some red wine. Maybe an easy kind of mistake to do. Then it would infer that red wine is a subclass of color. And now, if you remember, we declared that nothing can be both a color and a wine. So that's going to provoke an inconsistency. So again, I think that's, if you've got a good high-level set of disjoints and a good high-level set of domain and range on your relations, then you're able to find errors. It's quite a powerful way of finding errors that creep in ontology development. So really, that's all I was going to try and teach today. Any questions on that before I move on? And then I've got some exercises using this wine ontology.
Can you explain the difference between range and domain, please? I managed to.
Yeah. So okay. So let's do it with some edits. So let's have a look at this. What's this here? Okay, so we have region. Let's say a good example. Okay, I'm just going to add some. So now let's say all states are regions of countries. So I guess we mean state in a federal state, maybe also. Okay, so now if we go to region of, we make, if I do it around, yeah, that should work for both. So if I now make the domain, actually, let me, what else do we have on there? Sorry, that's what the classes. Okay, yeah, so I'll call them, so let's call this geographical region to be clear. Spell out. Oops, didn't happen there. Okay, let's just, so now if I go to object properties, let's make the domain of region of region. And run the reasoner. Actually, it's automatically done all, but let's say now let's look at the inferred classification. You can see, oh damn, I asserted it. Just a minute. Let's just do it this way. You can see. So right now that's flat. I run the reasoner. And now you can see federal state is a region. So it's let's have a look at these slides again. So yeah, so for range, if X has color Y, then Y is a subclass of color. If for domain, it's the other way around. So if Y, if X, if house color has a particular domain, then X must be a subclass of that. So domain is on this side, domain is on the left side, range is on the right side. Does that make sense? So then we can see here, if we look at the explanation for why this is a region. So federal state is a subclass of region of some country. So that's on this left-hand side. So that's the domain side. So then yeah, region of has domain region. That means that federal state is a region. So for the range, it would mean that would say something about the country. If I then add object properties, if I now add range region, reasoner, class hierarchy. Ah. There we go, live. I expected that to make, there we go. We run live examples, things will go wrong. X region. Okay, not quite sure why that hasn't worked. Whether that's a, okay, well, let's leave that, that's interesting. Because I've certainly run examples in the past using domain and found this, and found issues. And now I think there is an issue that one of the versions of, only the latest version of ELK supports range. So if you want to run any tests using range, you'll need that. Yeah, I expected this axiom to be sufficient to make country into a region. And that doesn't seem to have worked.
No, this is not enough. I think the range, this only works for domains. This kind of logic. This, if you want this to be used for, so because not, it would have to be the case that for all countries this relationship holds also for the regions, but that's not implied by this statement. So it's if you say if you say that, can you go back to the axiom? So if you say here that federal state, region of some country, this is always true, but it's not always true that country has region federal state. That's not always true.
Yeah, but we haven't put any inverses in here. So you think so that we're only going to get that across the
Yeah, you only get that if so probably you need to declare some inverses or something like that, but you only get the range reasoning, so the range the range
works already, I think.
No, the domain works right now, only the domain. So you won't see that the country yeah, you don't see any inferences on the country like that.
Okay. I have to say I've spent years working with reasoners that didn't use range, so it might be that I've been confused about this one myself, but yeah. Okay, so with the range on there, that's not working. Interesting. Okay. All right, so much for my examples here. Yeah, so the reverse will work using domain. Okay, so for some exercises, there's this wine ontology. There's a link here. I can add add the link to the Zoom as well. Oh, here we go.
While you're copying this link, can I ask? You can use the so if you see on your bottom of your screen, there's this reaction button. You can use the thumbs up or something like that to indicate an answer to this question if you don't want to talk up. But who here has Protégé installed and would be able to follow the exercise? Just so that I can see how many people here are able or willing to do that.
Yeah, I just kind of assumed that everyone that come to these calls is sort of a Protégé user. But...
Oh, so we have had four confirmations. So okay. No, so there's more. There's or Joe maybe. Yeah. So 5. Yeah, so let's see. Yeah, so do you all want to 6, 7? Okay, good. Now some more people are confirming. Okay. Yeah, then if you want, what you can do now is it's up to you. Either you can follow this exercise by yourself, or what we invite you to do is you can all share your screens at the same time. So I think that Sarah, you have to permit multiple screen sharing by clicking on the little arrow next to the screen share button. There's just this checkbox saying allow multiple screen share, and then everyone here can share their screen. And if you want any help by one of us, you can just raise your hand and we will come and sort it out. Now, Sarah said she confirms it's possible. And but you don't have to share screen. It's up to you. It's an invite so that we can see what you're doing, and we may be able to help you more straightforwardly like that. So just to let you know.
Okay, so am I still sharing screen? Yeah, I'm still sharing screen. Okay. Yep, so the wine ontology I've put in the chat. You should just be able to load it directly from URL in Protégé. So open from URL and just paste that in and say okay. And then you'll need the latest ELK installed. So run that. Is the snapshot actually the latest? Interesting question. And just to kind of show you around a little bit, so in this wine ontology, we've got color. Regions are actually individuals. That's maybe a little bit more advanced. I wasn't going to go into that in this tutorial. The basic idea being there is only one Piedmont or one Italy, so it doesn't make sense for it to be a class. We can record the color of the wine. We can record the varietal it's made from. We've got some defined classes like red wine and French wine and Italian wine, etc. Okay. Yeah, all I did was just to set some exercises, which are just a list of questions here. And it looks like we might need to skip number 3. I want to go do some more tests on this. I'm a little confused myself. Okay. So first one is, for humans, there's no such color as red-green. How would you extend the ontology to prevent the addition of colors that are classified as both red and green? And then do a little bit of work to show that this actually works. So it's not a kind of step through. It's trying to see whether you've got the basic idea here and you've got the tools to test to work with it. Okay, so if everyone doing this wants to share screen and just give it a go, and I'm happy to jump around between people. Anyone who's struggling, and I guess we're mostly going to do this over chat if people have got problems. Do I need to stop sharing for now? Or?
Can you share the link to the slides again?
Yeah.
So Joe just said that there may be some problems with having both if you have to jump back between screens. So you basically share your screen, and then you in order to go back to the main screen, you click on Zoom, and then you see in your view options, there should be like a list of all of the different screens that are shared at the moment. So right now there's only a Harry. Okay, now we can see David, Harry, and Joe have shared their screens, and everyone here can just click through Harry, Joe's, and David's screen. So if there are a few others that want to share screen, then yeah, feel free now, and I will go take a little bit of a look at what Harry is doing. So maybe someone else can look at what Joe is doing, and anyone else who wants to join this shared screen. Maybe Sabrina and Nicole can look at. You go ahead.
Yeah, I think for me to help, I probably need to stop sharing. Then I don't think I can see people's screens while I'm still sharing.
I think. Are you sure you can't see? Oh wait, you can't.
That was always my impression before. Yeah.
You can't share and look at other people's screen at the same time. Okay. All right, yeah, then unshare. I mean, we can always use participants to share their things in any case.
I don't see, how do you look at someone else's screen?
So if you look at this, there's this, you are viewing David Osumi's screen in the top of your screen right now, this green bar. There next to it is view, and you can see Joe, Sabrina, and Harry.
I just clicked on.
Oh, cool. I've never seen that before. Cool, thanks.
No.
Okay, so
yeah, so Harry yeah, it's good. All right, so
can I ask, like, I mean, it's stupid, but I don't even understand the question. So we basically want to make sure that red and green cannot be used at the same time in the ontology. That you cannot say
you want to make sure so you can't. There's no such thing as a color which is both red and green, at least for human eyes. So what we want is to stop anybody adding anything that is a subclass of both red and green, so classified as both red and green.
Okay.
So that if somebody does that and runs the reasoner, the class will turn red.
Mhm.
Okay,
Okay, so okay, good. So did you also add to the test? Maybe can we also exactly add for everyone just like a test that ensures that what you just did is correct? Do you understand? Like basically creating a class by which we can see that what you just did is doing the right thing, like the red and because right now they produce axioms, but they don't know whether their axiom work or not. So it basically they need to do something in order to figure out whether they have done the right thing.
So first, how would you extend the ontology to prevent the addition of colors that are classified in both red and green? And then secondly, add a class to test that this works.
So is anyone who maybe Harry or Joe or Sabrina who is already there to try and create a test class?
I think I just did.
Okay.
And it didn't. And everything is great. I can have both. So that's I did something wrong.
Which reason are you using, just for completeness?
L.
Okay, now it's good. Okay, good.
So I forgot to do something.
This is a very good mistake to do, though. It's a very
very good mistake.
No, it's a very great. No, don't try to fix it. It's a super good mistake to do. So David, go to Sabrina's screen and go and let's. I think
I'm just helping. Helping Joe out here, and I think Joe is missing it's to do with his setup actually.
Okay, good. I can help Joe. I think it's a. There's
do,
a very.
Do you want to help Joe? Do you want me to?
I'm jumping to Joe, and you can use Sabrina's great solution to explain why what's going wrong. It's a very good one.
Sabrina.
Okay.
Sorry.
Should I explain what I did? So everybody.
I just need to find your screen first. Now, why can't I see you?
In the view options, Sabrina Toro, like in the next to the green bar at the top of your screen.
Ah, got it. Yeah, got it. Hi. Okay.
Sabrina, explain what you did.
So what I did, I created a new class for color. I called it green. And then I made green disjoint with red. And if I look at red, now it's disjoint with green. So it seems fine. Then I created a fake green and red wine. And I added both those subclasses, has color some green, has color some red. And because green and red are disjoint, I thought it would fail, but it did not.
Yeah, what you've said is that a color can't be both green and red. You haven't said that there's no thing that you haven't said anything about things that are subject to or object to the relationship has color. So if you tried to make a color that was a subclass of green and red, then you would get an inconsistency. But if you want to say that something can't have color and have color green and have color red, you would need to say has color some green disjoint with has color some red.
Okay, and where do you do that?
So, well, first of all, do you want to try and just test if you make a color, make a subclass of make a color that's a subclass of red and a subclass of green.
Oh, I cannot do this here. Okay.
So does the colors have colors?
No, they don't. I was thinking that when I was typing. So, oh, okay, I see. I understand what you mean. Here. This is what we want, right?
Mhm. Yeah.
Reason has synchronized.
There we go. Now it's turned
Yeah.
red.
So, okay. So if I want to, I think that's where my issue is. If I want to say that a wine has green and red, is it something that I can say even though green and red at disjoint?
Yeah, so all you're saying is in that, if we go back to the, if you look at the slides and you look at the, yeah, if you look at that, the first slide with the disjoints on, there we go. Oops, that's a keep going up. There
This
we
one?
go. So all you're saying is that, so that,
Wine and
so
color
think of it as
cannot
these,
be the
as these,
same.
yeah. So that's actually, so in that case, you're saying nothing can be a wine and nothing can be a color. You're not saying anything about the relationships to wines or colors in any way. All you're doing is talking about that classification. So you're saying nothing, you know, think of it as those nested classifications.
Mhm.
You've got red wine under wine and white under color. You're not saying anything about the relationships between wines and colors there at all.
Yeah,
and now
yeah,
if you
yeah.
go down, we actually do have the second example. If you now go down to the next, there we go. So has color some red, disjoint with has color
Mhm.
some white. So in that case, nothing can have both of those colors. That's what you're saying. So if you were to add that,
Okay. And where do you add that? Where is the general class axioms
So to-
for the entire ontology, right? Or is
have
it
a look.
here for wine?
I think there we go. Go to that fake red green wine. Now you can see. Can you look in the descriptions, just where you normally add things? You go back to
Sorry,
the ontology. If you go back to protege,
okay.
now just look where you normally add axioms. So like subclass of, and
Mhm.
there it is. There we go.
But where on which class do you add that?
Well,
Would you
can
add
add it
that on the wine or on a specific wine?
I would add it on. Let me see. So how did I do it here? Yeah, add it under. Just add it under red or green, either of those. So basically, the way
What do you mean?
protege works, if you add it, if you go to the class red,
Okay.
and then just add it there.
So if you add a general class axiom here, is it going to be only for this class or is it going to be for the entire ontology?
It works for the whole ontology. I mean, all axioms kind of do, but it will show
Okay.
up under white as well. It's just a display thing, really.
I guess this is a good point for my question. Do we add things on classes like GCIs on classes, or do we add them? Because I know Protege has a general class
Yeah.
axioms.
You can add them on the active ontology tab as well, but the problem with adding on the active ontology tab is you have loads of them. It's really hard to keep track of them. It's just kind of for convenience that you add them here, to be honest.
Fair enough.
But then by adding them, if you look on the class, so if you're looking at, if anyone else is looking at, looking at Sabrina's screen, there we go. So now if you look under green, you'll see it there as well. So basically any class that gets mentioned there, it'll show up, which just makes it a lot easier to edit and a lot easier to be aware of them. There we go. So now fake red, green wine is so there is actually in this case another way we could do this, and this is actually, so if I slow up here, how's Joe? How are you doing? Should we switch over? Anybody else
I made some
attempting
progress.
to do this?
I've got color and wine disjoint now, so that's something. So Sierra, does the next question make sense to you? Not Sierra, sorry, Sabrina.
Yes, I think it does. It's basically the same, but doing it with the wine and not with the color.
Yeah, well, it's so the other, rather than add the GCI, you can actually just, if you've got those two defined classes that are white wine and red wine, you could just make those disjoint with each other. So it might be a safer way to do things, actually, if you think about it. But
So does that mean that we should, I guess we should try to add the disjointness with the classes instead of using GCIs first, or is there a strategy?
well, I think they're two different things. So one is saying nothing in the universe can be both red and white, or red, whatever, red and green. The other is saying that no wine can be both a red wine and a white wine, which is a much more constrained, much more limited, and probably safer thing to say. So I mean, and I guess that comes to question 4. When you say nothing can be both red and white, what kind of assumption are you making about applying when you apply that relationship, has color red or has color white? Anyone?
I mean, I think from a perspective of wine, color does not technically determine the red or white wine.
Yeah, okay. It could be a lousy bit of ontology modeling as well. Definitely the color bit is a little bit yeah, potentially questionable. I guess white wine isn't completely white. It might be usually more yellowish. But you can make red wine from white grapes, white wine from red grapes as well. So
Would be more the process of the skin, right?
yeah. So what about in general, saying that nothing can be both red and white? What kind of assumptions are you making about using that object property has color? No one?
That everything cannot have color red and white, which might not be true.
Well, how would you choose? You're an object in front of you. You have to choose whether to apply a has color relationship to it. So I don't know. I mean, I'll make it easier. Say, well, what if I've got a flag? Can I use the has color relationship for a flag? For I don't know, an Irish flag or a French flag?
Singaporean flag has both red and white.
Well, there you go. So the assumption you're making straight away is that when I apply this, I want to say this is the color has to be kind of uniform or the same across the entity I'm applying it to. Or if that's not your assumption, you don't want to say that nothing can be both red and green. You see, and I think it's important when you make these, to document as much as, but that's a tacit, it's a piece of tacit knowledge. You might have a group of curators who all share that assumption, then somebody else comes on with a different assumption, everything breaks. So being able to document that kind of thing is to be able to document your assumptions, so you might want to comment on the relationship that says, if you've made that, if you've made those disjointness axioms, you might want to comment that says this should only apply. This should only be used for things that are uniformly one color. So the more you can document that kind of thing, I think the better for sustainability. And then my idea of, in this example, using domain and range is not going to quite make sense, because it's not going to quite work, because the range won't work unless I don't think it's an owl reasonable version, is it?
Joe, ask this to David. This is a typical confusion for everyone. Why is nothing?
I mean, yeah,
Just
why is
about
nothing a
the-
subclass of thing?
Why is nothing a subclass of thing? Owl
Yeah.
weirdness, just ignore it.
That's the
I don't
answer of a
know.
biologist. The truth
It is the
that,
answer.
so just so that everyone also knows this. So thing is a theoretical class that encapsulates basically every existing entity in your domain, everything. So this would be all wines, all humans, everything in the universe, basically. And nothing is a theoretical construct of the empty set. So it's basically, it contains no entity in your domain. It's a theoretical thing. And basically we use this in OWL
Does the
denote,
set of all sets contain the empty set? Yeah, that's the
this
famous
goes back.
problem in maths. Yeah.
Yeah, exactly. But basically, when you see a class underneath our thing, technically speaking, it's actually equivalent to our thing, but doesn't matter. You see it in the class hierarchy underneath our thing. Then what it means is that there can be no instances of that class.
A class under owl nothing. Sorry.
Yeah, our nothing. Yeah, what you see here on Joe's screen.
Yeah. So I don't know if you go to Barbaresco, Joe, and then if you click on the question mark next to owl nothing, can you see on the right hand side there's a question mark? There we go. That will explain why you've got the disjointness.
So this is a very, very important
Very
feature.
good.
Like it's basically one of the most important reason, if not the most important reason, why we use OWL and not LinkML for everything in the world, because this is what this is doing is it's extracting a minimal reason for why your class is inconsistent. Now in this small ontology, it's not really so spectacular what this is doing, but if you have like Uberon with like tens of thousands of classes and you introduce some axiom somewhere and then suddenly everything or many classes go unsatisfiable, it's almost impossible to figure out what's up without explanations, or it is impossible, virtually impossible. So what an explanation is basically the smallest set of axioms in your ontology that can be used to define or describe your unsatisfiability. So this is like you can think of it like a module basically of the ontology that all by itself shows why your class is unsatisfiable. So there can be many different ones, as you can see here, and any of these, a single one is enough for you to debug it. So you can we have like this nice so let's say it like this. Usually what we do when we are debugging explanations is we are looking at the explanations and then going through the axioms one by one in the explanation and say, is this axiom correct? Barbaresco is a subclass of green. That's already wrong, but let's just say it is correct. Then Barbaresco is a subclass of red. Is this correct? Yes or no? And then we go through all of these axioms in the explanation to figure out which statement is wrong according to our domain model. And then usually some biologist or someone will figure out, yeah, maybe Sean, just give us a real life example real quick.
I guess I should share my screen.
Slightly terrifying, but yeah. You're going to scare everybody off here.
Yeah, if you look at this example here, this is something Nico posted of some errors that we had in Uberon. You get something long like this in big ontologies like Uberon, which shows you what is wrong. So just a context, ZFA is a zebrafish anatomy ontology. And basically, if you look down here, this is part of a denu, which is the zebrafish kind of thing. And then you look down here, it goes down to here where jugular part is part of some neck, and the disjointness, which you can see, this is usually the axiom. Oh, that's not as clear this time here, but basically, the issue here, you can see that jugular vein is part of some neck, where neck is a subclass of only in taxon this, but these taxons are disjointed through a chain, and therefore the problem here is that fishes don't have necks according to Uberon, and therefore it cannot have a jugular vein because the jugular vein is part of a neck. If that makes sense, a real life example for everyone.
This is great. I think this cannot be stressed enough how important it is that we can generate such explanations based on the disjointness axioms we have in our ontologies, and how difficult it would be to even recognize such an inconsistency in any other system, like a knowledge graph or one of these less.
I mean, we also have a lot of, we also have a lot of automated classification in these ontologies as well, and exactly the same reason I will give you. There's the question mark next to your class is classified as a white wine, a red wine, or whatever, and you can check back through the explanations of why. So obviously in these little toy ontologies we've built, those explanations tend to be kind of a little bit obvious and not too hard to trace by hand. But again, you can have odd classifications that come through in something like Uberon or CL, and you want to understand where they come from. It's good to be able to look at the full explanation.
Does anyone have a last question for David here? Because we're almost at time. So is there anyone here that wants to ask anything else about disjointness that you're curious about, or any other thing related to this? Okay. Did you want to say something, David, just now? Sorry, I didn't want to interrupt.
No, it's okay. I guess we're at time. Okay.
So thanks very much, David, for giving this very interesting talk.
I hope that was useful.
Yeah, definitely.
I'm going to look into that example, and maybe I'll make a domain example for the actual O book. So
It sounds
have
great.
one of
Yeah, I
those.
think it's a very good idea actually to teach using something more, you know, tangible, like what you did now, than using some super obscure cell ontology classes. So yeah, thanks a lot for renewing the tutorials about this, and everyone else. Yeah, you will hear about the next sessions via email. So thanks everyone for coming, and let us know if there's anything else that you need to that you want to learn, or that you would like to have a course on, and as you know, in the discussion sections. So